Okay, morning everyone. Can you hear my voice? Okay, so we're going to start with our first topics. This is Earth internal and external structure. Okay, with this topic you're going to learn about what actually inside Earth. Okay, so the shape of the Earth is actually sphere. Okay, so basically we think or we thought that the Earth is actually round. Okay, it is actually not round, like not like last time when you draw in the school. It's not actually a perfect rounds. Okay, so it's actually an oblate spheroid. So oblate spheroid, oblate is means slightly oblong. Okay, slightly oblong, like those oblong burger that you have eaten. Okay, and spheroid is almost sphere. Okay, so that's why it's oblate spheroid. So it's not actually round. So technically, it's in the technical terms. Okay, rotation momentum tend to force the matter bunch up in the middles. Okay, so at the middle in here, it's actually bunched up, and is at the equator, and it also costs 2.5 kilometer flattened at the pole. Okay, so at the bottom in here is about 2.5 kilometer. It's actually flat. So that is actually at the North Pole as well as the East Pole. So Earth is made up of air, water, and solid ground. Okay, you have three elements: atmosphere, hydrosphere, and lithosphere. So it actually comes from Greek roots. Atmos means vapor. So hydro means water. Lithos means stone. 50 kilometers, hydrosphere 40 kilometers, and troposphere is 10 kilometers from the Earth's surface. Okay, then Earth is surrounded by layer of gases called the atmosphere. These shield planets from deadly radiation and meteor. Atmosphere also act as a blanket to keep Earth temperature stable. Okay, so this atmosphere, as you know, as the ozone. Okay, so it's actually acts as well as blanket to ensure that the temperature is stable and you have the ambient temperature, so it is not too hot then due to the ray from the sun itself. Okay, so this blanket is made out of 21% oxygen, 78% nitrogen, and 1% other gases. It also contains dust and water vapor. So this thing I believe you already learned before. The hydrosphere. Okay, the hydrosphere is at the bottom part in here. And you can see that when viewed from space, Earth might be called blue planets. 70% of its surface is covered with water. Okay, this is hydrosphere. Earth is the only planet known to have a liquid water. The ocean, lakes, river filled with plants and animals. Hydrosphere provide foods, fertilizer, and industrial materials. Okay, so at the last part of physical geology, you're going to learn about hydrogeology. Okay, and you're going to learn a lot about this hydrosphere. So as you can see in here, this is the sea surface. So in oceanic trends, you can actually reach up to 10 kilometer deep. Okay, at 200 meter is basically a continental shelf. Okay, then you have continental slopes. If you go deeper, around 4,000 or 4 kilometer, so you have a continental rise, and around to 6,000 meter, you have abyssal plain. Then you have this oceanic trench. Later, we're going to learn what actually or how this oceanic trench created, and how does this oceanic trench have an effect on our civil engineering projects. because every time when you have oceanic trench, meaning that you are going to have some other things. So in geology, basically each and every time when you have one thing, that thing is actually created by another things. So similar to the rotation of the earth, you need that whole energy of to actually rotate the earth. Okay, so the next one is lithosphere. Lithosphere is the solid part of earth. It's consisting of the uppermost layer of the mantle plus the crust. The crust is where we are right now. The crust is made out of rocks and soil and constitute the top 40 kilometer. Okay, this is actually at the top part. So if you have many layers of earth, okay, so the top part, this is actually where we now, so this is actually the crust. Below mantles lies the core. The core is the solid inner, so this is the core, okay, inner core and a molten outer, okay. So this is the interior of the earth. So in this interior of the earth, as you can see that this is where we are now, okay, the crust. Crust is a very thin, brittle layer of earth surface where you have oceanics and continental crust, okay. And the most deepest part of the earth, you have the inner core, okay. So this is inner core. So inner core, it is believed that the inner core is a solid ball of mostly iron and nickel. So it is believed. So this part is iron and nickel. And outer core, it is believed that this outer core is made up of superheated liquid molten lava. Okay, so this lava is believed to be mostly iron and nickel as well. Then you have the lower mantle in here. Okay, lower mantle is a dense and hotter than the upper mantle. This is the upper mantle. Okay, then the upper mantle is the asthenosphere layer, and below the asthenosphere layer lies another layer and stronger, and it is more solid. So later you have this final layer is the crust where we are now. Okay. So as you can see that this is solid layer. Then you have a lot of magma in here, and this magma is basically is a liquid. Okay. So this is in kilometer, thickness in kilometer. 1,221 kilometer from the inner core. Then you have the outer core, 2,200, 500. Then you have the lower mantle, and crust, the 30 kilometer. Okay, so this 30 kilometer means that it's just that layer of 30 to 40 kilometer. Okay, in here you can see the density. Okay, the top part is about 12.8 gram per centimeter cubes. The bottom part is 13.1. So the outer core is 9.1, 2.2. So this is all the materials that you can find. So you have iron, oxygen, sulfur, nickel, alloy. The density, this is start at 2.2. Okay, this is the top part. So the top part is 2.2. Then the bottom of the crust, this is us. Okay, here, yeah, it's us. Then the bottom part is 2.9. Okay. The earth, as you can see that this is the length, okay. Then you have about 2,000 kilometer, you have about 2,800 kilometer. Continental crust is about 30 to 40 kilometer. Okay, depends on the geological features. You have Hydrosphere, okay, this is 660 kilometer. This is upper mantle, this is lower mantle, okay. So you can see that the continental crust is actually just 0.5%. Okay, this is 30, 40 kilometer is just about 0.5% of the total depth of the Earth. Okay, and basically, even that, this number 6,371 kilometer is just an estimation numbers. Okay, nobody can actually say that this is an exact correct value because this is basically just an estimation numbers. So if you dig just about 5 kilometers, okay, that is already hot enough for you to generate a geothermal power plant. Okay, so come back to here. So this is KLCC piles. KLCC piles is about 115 meter. So it's not even 1 kilometer. Then you have, this is onshore oil well. Okay, this is onshore, the shoreline, the line. This is Monchin, so about 7.5 kilometer almost. You have BP Horizon offshore oil well. Okay. Then the last one is, this one is actually the deepest that man ever drilled is actually Kola Super Deep Borehole, if you can try to search. So this is during the Cold War, Soviets, because during that time, people go to the moon, so they go up and they're going to go down as well. So they want to go as deepest as they can. So the Kola Super Deep Borehole is actually the only scientific purpose of drillings. So they can just drill up to 12 kilometers. So 12,262 meters. This is actually the deepest drilling that human can ever reach. As you can see in here, continental crust is about 30 to 40 km. Oceanic crust is about only 5 km. Okay, so oceanic crust, you can see these numbers. Okay, it's actually oceanic crust have a very low number because it is actually dense. Okay, compared to continental crust, oceanic crust is basically more dense compared to continental crust. Okay, basically when civil engineer understand geology, okay, then we can actually plan our work and we can plan our construction works in order for us to ensure that every time when we do the construction work, we will not have any problems. Okay, and it have a safety issue. So that's why we need to understand geology so that during the construction work, we can actually predict what is the geological condition of one site. Okay, so as you can see in here, so this is considered like a stable phase situations. Okay, so this is the one that you saw before. So it is unstable phase situations. You have all the rocks already mixed with the soil, then everything is actually fails. Okay, and this one is the phase and the perimeter of the cavity deformed, plastically intruding into the tunnel, giving a rise to a stable phase in the short-term situation. Okay, like this one, failure at metro line sites. Okay, in Germany. So this is in Malaysia. Okay, sinkhole near MRT site in Kuala Lumpur. Okay, so moving on to Earth internal temperature. Okay, as you already know, this is the Earth. Okay, crust. So this is the crust. As you go deeper, the temperature is actually increasing and increasing and increasing. Okay, So in here you can see solid part slowly deform in plastic manner, then this is molten, and basically even for steels we can just burn up to 2800 degrees and it's like really hot. Then you can see that in the middle is about 4300 degrees, so it is very hot. Okay, so this is the come to the part where you have the condition where the earth internal is hot. Okay, so this part is off and the earth moves slowly upwards towards the cool surface, and the rock that is deep within the earth and is very hot rise slowly towards the surface, while the rock that is cool near the surface is dense, then it sinks downwards. This cycle is what we call a mantle convection.